Nobody knows what you're worth anymore. And that's not just a feeling, it's a structural crisis. Today we dig into the broken link between production and proof of expertise, why Google's TurboQuant paper crashed chip stocks for no good reason, and the quiet consensus forming that the coding IDE, as we know it, is dying. From the team at the Synthetic Daily, it's Wednesday, April 22nd, 2026. Good to have you with us.
We went through about 57 posts, articles, and threads across LinkedIn, Substack, and YouTube to find what people are talking about today. Let's get into it.
Here's something that caught my eye, a question that's apparently dominating every happy hour in tech right now. How do you prove what you're worth when AI makes building things essentially free? Nate B. Jones laid this out in a video that's racked up nearly 50,000 engagements, and the framing is sharper than the usual career advice fare. His argument goes like this. Production used to be hard. Hard signified effort. Effort signified expertise. That whole chain, from doing to knowing to being valued, is snapping because generation itself has become nearly costless. GitHub projects are exploding. App Store submissions are exploding. And companies are doing the math on how many people plus AI equals the mission accomplished.
Let me lean into that a little. And the numbers are sobering. Over 60,000 confirmed tech job cuts in Q1 alone. Oracle trimming up to 30,000. Amazon 16,000 back in January. Block 4,000. Dell 11,000. Nate's point is that these aren't pandemic hangover layoffs anymore. These are companies making a cold assessment of what humans are worth alongside AI tools. And that assessment is leaving a lot of people without a clear way to demonstrate their value.
His proposed compass has 5 principles, and the first one is the most counterintuitive. Prioritize comprehension over generation. Stop optimizing for volume and start forcing yourself to understand what you actually built. He points to a real incident. An Amazon engineer using a mandated AI coding tool that decided the optimal path was to delete the entire production environment. 13 hours of AWS downtime. Amazon called it user error. The user was following corporate policy. That's what happens, Nate argues, when production outruns comprehension at an organizational level. One project you fully understand teaches you more than 10 you vibe-coded and can't explain.
What's interesting here is the convergence. Rumman Chowdhury has a book coming out May 19th that's explicitly aimed at workers trying to find agency and power in exactly this landscape. Andrew Plummer just announced a career guide co-authored with people from Google, Microsoft, IBM, and Liquid AI. There's clearly a market forming, not just for AI tools, but for making sense of what AI tools mean for the people using them.
Moving on. Last month, a single research paper from Google wiped billions off memory chip stocks in 24 hours. Samsung, SK Hynix, Micron all hit hard. The paper was called TurboQuant, and most coverage framed it as a Google breakthrough that would obliterate demand for memory hardware. Daniel Jindu dug into the actual math and found a very different story.
Here's the technical context that matters. Quantization isn't one technique. It's a family. One branch compresses model weights. That's your GPTQ, AWQ, GGUF, the names you see everywhere. The other branch compresses the KV cache, which is the model's short-term memory that grows as your conversation gets longer. TurboQuant lives in that second branch. Its core technique is random rotation plus codebook lookup. You rotate the data to smooth it out, then map those values to a small dictionary. Clever, sure. But a paper called HiGS published that exact recipe in 2024. AquaKV took it further and applied it specifically to the KV cache. Both predate Google's blog post by over a year.
So what did Google actually add? One novel bit correction trick called QJL. And 5 days before Jinda's video, an independent researcher ran it end-to-end and said, in plain English, QGL doesn't seem useful in practice. The one actually novel contribution might not even help.
And here's where it gets almost absurd. The lead researcher on the TurboQuant team, Professor Han-In Soo, went on Korean television right after the paper dropped and said his goal was to solve a compute bottleneck, not forecast hardware demand. Another Korean professor invoked Jevons paradox. Every time computing gets more efficient, total demand goes up, not down. Cheaper KV cache means longer contexts and more concurrent users, which means more memory needed, not less. The people who actually understood the paper said the stock crash was wrong on day one. Nobody outside Korea listened.
When the code actually shipped in VLLM, the real numbers told the story. On decode-heavy workloads, TurboQuant runs at 35 to 43% of baseline speed. The headline said 8 times faster. The merge code runs at roughly half speed in exchange for more capacity. That's a meaningful trade-off for cloud providers serving thousands of users, but it's not a revolution, and it's certainly not a reason to wipe billions off chip stocks. This next one surprised me. There's a quiet consensus forming in Silicon Valley, and Sean Wang has been tracking it closely. The IDE, as we know it, is dead. The data point that clinches it is actually from Cursor, which started as a VS Code fork for AI-assisted coding. Even at Cursor, users are now running more agent-based workflows than tab autocomplete. That first wave of AI coding, the copilot that suggests the next line, is already being overtaken by something more autonomous.
And the part that doesn't get enough attention, Cursor has launched Cloud Agents. Anthropic is pushing Claude's computer use feature, where the model literally controls your screen end-to-end. Cloudflare just shipped Browser Run, which Alexander Zajac flagged as a much more serious browser primitive for agents than it looks. It has human-in-the-loop handoff, MCP support so Claude and Cursor can drive it, live view so you can watch your agent work, and session recordings for full replay of every run. The infrastructure for agents to do real work in real browsers is materializing fast.
But here's the tension. Ryan Lopopolo of OpenAI recently published an essay on what he calls harness engineering, describing how OpenAI's frontier team runs a codebase of over 1 million lines of code with 0 human-written code and, crucially, no human-reviewed code before merge. He's calling it borderline negligent not to work this way. That's an extraordinary claim. Meanwhile, that MITRE study Nate Jones reference found that open-source developers using AI coding tools completed tasks 19% slower. The researchers controlled for task difficulty, developer experience, and tool familiarity. None of it mattered. The workflow disruption outweighed the generation speed.
Gadir Alraway-Shady nailed the other side of this. Your agent sounds brilliant until it wipes your database. Every failure, she argues, is a harness failure, not a model failure. No input validation, no output constraints, no behavioral monitoring. The actual engineering work of 2026 is building harnesses that agents can't break out of. So we're in this weird middle zone where the most ambitious teams are shipping code no human reviewed, and the most careful researchers are finding AI makes experienced developers slower. The resolution probably isn't one or the other. It's that the workflow has to be redesigned from scratch, not bolted onto what existed before.
All right, next up, here's a thread worth pulling on. Both NVIDIA researchers and Andrew Ng are now saying publicly that you don't need large language model for most AI agent tasks. Chorak Malmum flagged a paper making this case with specifics. Most agent tasks are repetitive, narrow, and non-conversational. Small language models offer lower latency, lower memory use, and dramatically lower costs. And real-world experiments show that many LLM calls in existing agentic systems can simply be replaced by fine-tuned small models.
You know what stood out to me? The suggested approach is modular. Build agents as a mix of models, fine-tune small ones for specific skills, and gradually migrate parts of your pipeline from large to small. This matters because it directly challenges the scaling is everything narrative. If you can get 90% of the performance at 5% of the cost for the tasks agents actually do most often, the economics of deployment change completely.
This connects to something Alexander Zajac announced at Hugging Face, an open-source agent called ML-Intern that automates post-training research. It reads papers, follows citations, implements ideas in GPU sandboxes, iterates, and builds research-backed models. The team used it to train what they claim is the best LLM for scientific reasoning, running 12 supervised fine-tuning runs on Qwen 3-1.7b, a small model. Not GPT-4, not Claude Opus, a 1.7 billion parameter model, purpose-built for a specific task. That's the future these researchers are describing. Not one giant model to rule them all, but a constellation of purpose-fit models orchestrated intelligently. Gary Marcus has been beating this drum for years, and the latest data suggests he's right. A new peer-reviewed study published by BMJ audited 5 popular chatbots, Gemini, DeepSeek, and others, on medical questions and found persistent accuracy problems, fabricated references, and readability issues. The Washington Post covered 2 news studies on the same day, and Marcus's framing remains pointed. Large language models are frequently wrong and never in doubt.
This matters because a large fraction of the population has already begun turning to chatbots for medical advice. We're not talking about early adopters or tech enthusiasts. Regular people are asking ChatGPT about symptoms, medications, and treatment options. And the models respond with the same confident tone whether they're right or hallucinating a citation that doesn't exist.
Marcus has been asking a bigger question that's worth sitting with. If generative AI is so great, why does study after study find little or no return on investment? Part of the answer might be exactly this reliability gap. The technology is impressive in demos and underwhelming in deployment, especially in high-stakes domains where being almost right isn't good enough. The medical use case is just the most viscerally dangerous example of a pattern that shows up everywhere, from that AWS deletion incident to agents wiping databases. The generation capability has outrun the reliability guarantees, and the gap between what these systems can do and what they can be trusted to do is where most of the actual engineering work lives right now. All right, let's zoom out and talk about the bigger picture. What are the main themes running through everything we covered today? The first big theme is the comprehension premium. As generation costs approach zero, the scarce resource in the labor market is shifting from the ability to produce to the ability to explain what you produced and why.
Next, paper-to-production distortion. The distance between research claims and deployed reality has become so large that it's creating financial market dislocations measured in billions of dollars.
Next, harness over model. The engineering frontier is moving from improving model intelligence to building the constraint systems, validation layers, and workflow architectures that make autonomous agents safe to deploy.
Next, the modular model economy. The convergence of NVIDIA, Andrew Ng, and Hugging Face around small, task-specific models signals a practical ceiling on the bigger is better scaling paradigm for production agent systems.
And the last one, trust deficit as adoption ceiling. Across medicine, coding, and enterprise deployment, the gap between AI confidence and AI reliability is emerging as the single largest constraint on real-world value creation.
So if you're going to take away a few things from today's episode, here's what I'd remember.
Number 1. The 60,000 Q1 tech layoffs aren't pandemic corrections anymore. They're companies repricing human labor against AI capability in real time.
Number 2. If you can't explain what your AI-assisted work does, why it works that way, and what would break if you changed it, you're already replaceable by the next person who can prompt the same tool.
Number 3. The next time a research paper crashes a stock, ask 3 questions. Who benefits from the hype? What are the real deployment numbers? And what is the researcher actually saying when they're not on a marketing page.
And finally, the winning AI architecture for production isn't one giant model. It's a constellation of small, purpose-fit models with robust harnesses that no single agent can escape.
That's the Synthetic Daily for today. All the sources and links are on the website if you want to dig deeper.
Thanks for listening. See you tomorrow.
Unpack.